Hi, Ethan again. I'm in my bedroom slash shop and I'm playing with the hairpin circuit and doing some load testing. So, what I want to show, this is my little setup right here. The energy at this distance is more intense than my 4-foot bars are on my bigger setup. But we get the same transformer, same capacitors and all that. Now this is hooked up right now on a dead short, and what I want to show is the on this kilowatt meter here. I'm going to show everything because this is connected to the transformer primary. So I mean, I would love to have equipment to measure that, but as of right now, I only have the primary side. So I'm going to flick it on. You won't be able to hear me probably. So we're just going to look at the numbers. Volt, amp, watt, and hertz, and then kilowatt hour is what we're going to look at. This is the dead short. The next, I'm going to put in 3 of these, I think these are like 5 watt, 13 watt, whatever, CFL bulbs. There's 3 of them in series. So we're going to look at those next. Compare the numbers. Alright, now that we've got some numbers, I'm going to disconnect the dead short. Now, because the energy is intense right here, because of the short distance of the copper, these wires start to get warm. Not, hot, but you can tell a difference. In the 4-foot bars, there's almost no difference at the top. But in the lecture book, he talked about impedance, which I'll show the reference material here in a minute, but 3 CFL in series. Here's our load numbers. Oops. What happened? Oh. Knucklehead me, I disconnected it. Okay, here we go. Alright, for poops and giggles, I'm going to connect 1 single CFL bulb as our load. So that way we can see the intensity of the light as well as a single CFL bulb. So here we go. Okay. Now, for final reference, we're going to go back to the dead short. Now, obviously, these are not resistive loads, but the energy because I'm using the too short copper, the energy is too intense for my halogen bulb, and it just discharges and doesn't even, it just bypasses the filament because the potential's so high. So, dead short numbers. So, whoa, oh no. So, I think that shows that according to my little kilowatt meter, which is digital, and it could be whacking out because of a field generated by the spark gap, but according to it, the wattage went down with the load applied. So, interesting. Bye-bye.